So, my dear students, very good evening to all of you. Now, we are having one question related to the rotational motion, and this question will clear the concept of dynamics of rotational motion. That is, F, the force acting on any body into perpendicular distance, is equal to the tangential force into perpendicular distance is equal to I into alpha. Okay, that equation for the rotational motion, and also this question will clear how we can find the relative acceleration on the circumference. There are so many points we can consider, and the center of mass also one of the point on this cylinder. So how we will find the relative motion, and with the help of concept of relative acceleration, how we can find the individual acceleration of different points. So the question is that consider a cylinder of mass m resting on a rough horizontal rug that is pulled out from under it with acceleration a perpendicular to its axis of the cylinder. What is the frictional force F friction at point P? Okay, assuming the cylinder does not slip. This point is very important, does not slip, so that we can use the concept of pair rolling. And in this concept of pair rolling, this point P, which is in contact with this block, is always having the same motion as this block. Okay, so the acceleration of this P point will also having the same acceleration A as the acceleration of block is there. Okay, so the acceleration of this point P, which is on the circumference of this cylinder, will have the same acceleration A. Okay, now in the cylinder, if we are just taking the acceleration of center of mass, okay, let us consider the acceleration of center of mass. Definitely it will be this, it will be in opposite direction. So this acceleration of center of mass with respect to ground, okay, and acceleration of this point P with respect to ground is A given. Now what is the acceleration of this point P? Listen carefully, this point is very important to understand, that acceleration of this point P with respect to center of mass. Okay, so you can write this acceleration of point P with respect to ground minus acceleration of center of mass with respect to ground. That is the concept of relative motion. Okay, acceleration of point P with respect to center of mass, that is the alpha into r, angular acceleration into distance, and it will be positive if this backward direction we are considering as positive direction. This backward direction we are considering as positive, so this alpha will have the direction in clockwise direction, and this alpha will produce the acceleration with respect to center of mass in clockwise direction. Okay, in positive direction itself. So this a into r, which is positive. Now acceleration of point P with respect to ground is a, and it is also positive because this backward direction we are considering is positive direction, minus a with respect to a of center of mass, acceleration of center of mass with respect to ground we need to find. Okay, so now from this equation we can find the acceleration of center of mass with respect to ground, and it is a minus alpha into r. Okay, that is our equation number 1. Now if you are taking the linear motion, the linear motion for this cylinder, so we can write this linear motion, that is friction force. Only the friction force is acting, friction force in between this block and cylinder, only the friction force in between is acting, which is in backward direction, and this acceleration, this friction force is producing the acceleration of center of mass. Okay, so friction force F is equal to mass into acceleration of center of mass with respect to ground. That is our equation number 2. Now we are taking equation for rotational motion. Okay, because it is case of rolling, so rotational motion, equation for rotational motion, the dynamic we already know very well. So F, what is this F? Friction force is providing the torque into perpendicular distance is equal to I into alpha. This friction force is responsible for the alpha. Okay, so from these three equation we will find the friction force. Okay, so first we will replace this this alpha. Okay, sorry, first we will replace this 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 equation 1 and equation 2, and from this equation 1 we will put the value of acceleration of center of mass with respect to ground. So this F will become F is equal to mass into a minus alpha into r. Now alpha is equal to what? This alpha is equal to F into r divided by I. So if you are placing the value of alpha, you will get F is equal to m into a minus F into r divided by I into r. Okay, now we are multiplying this m inside the bracket and finding the value of F. So F is equal to m into a minus m into r square into F divided by I. Now what is value of this I for the cylinder? That is mr square by 2. If the cylinder is rotating about this axis of this cylinder, solid cylinder, mr square by 2. So if we are just now placing the value of this I, we will get m into a plus, sorry, minus mr square into F divided by mr square by 2. So this mr square will cancel out, and it will become 3F, that is equal to m into a, capital M we have to use. So F will become ma divided by 3. Okay, so this question definitely clearing our concept of rotational motion as well as the relative acceleration.